Good day, grade 12s. We are looking at an analytical mechanical activity where we are going to be discussing this page which you have here presently on the screen. The drawings have not been prepared according to the indicated scale. So what is given to you is the drawings of parts of a punch, a sectional view of the punch assembly, a title block and a table of questions. The instructions are clear that you need to complete the table below by filling in all the answers to the questions, which all refer to the accompanying detailed drawing on your left hand side. So take a moment to go through these components that you will see here, and then you answer all these questions. I'm going to go through it one by one. Please fill in the answers as I make my way through all the questions. Question number 1, what date was the drawing checked? You are going to see that the drawing was checked by John and it was on the 13th of the 3rd, 2015. Question 2, in which town is the engineering company situated? The company West Coast Engineering is situated in a town called Veldrift. Number 15, Main Road, Veldrift. In which SI unit are the dimensions presented in this drawing? So if you look at the drawing, you will find that all these dimensions are in a unit millimeters, millimeters. That's the metric meter that we are using for this particular activity. So you need to write millimeters as the answer to number 3. Question number 4, what type of heat treatment is required on this particular component? You're going to find that answer in the title block at the bottom, or in the information block at the bottom, where it is temper. Temper is the heat treatment that's going to be used. Question number 5, what is the file name? The file name you are going to find here, which is punch3.dwg. That's the answer which you are going to write in there. Question number 6. What material is used to manufacture the punch? Let's go down to the title block and find that answer. And that material would be cast iron as your answer. Question number 7. On what date was the last revision? Here you will find the revision table, all done by Andrew on those specific dates. And these are the revisions as they were done. The first one on that date, so the last one that we are looking for, and that's going to be the 22nd of the 4th, 2015. Question number 8. How many surfaces require machining? So now we're going to look at that machining symbol and we're going to count how many surfaces have been machined. So if you look at these machining symbols that you will see here attached to a surface, we will have to count them. So we're going to start here by saying that's 1, which is the bottom of that, 2, which is the top of that base, 3, which is this part here, but because there are 2 of those, we're going to count them double. There's 1 here and there's 1 over here. So that's 1, 2, 3, 4. So that's the 4 because of the double ears that we have here. Then we have 5 and 6 over there. Then 7 over here. And we have 8 over there. So there will be 8 surfaces that need machining. Number 9, what type of section is shown on the base plate? Let's go have a look. This is the base plate here, and you can see that the section runs right through from one side to the other, and that type of section is called a full section. The word full section you are going to fill in as an answer. Number 10. Determine the dimensions at A, B, C and D on the drawing. If you look at A here, it is the distance from here to there, which is the base part of that arm. And if you scroll down, you're going to find that that is the base part here, which is 36 millimeters as your answer to A. If you look at B, the distance from here to there of the arm, and you will find that distance is going to be 58 from here until the center of that hole there. You must add the distance from this center until the arrowhead, which is the radius, and that 24 gives us the diameter, so divide that by 2, which is going to give you 12. So 58 plus 12 will give you 70 millimeters. That is the 58 plus the radius here of 12 gives you 70. If you look at C, C is the distance from this bottom section of the bush until the bottom part of the head. You will see that the bottom to the top part is 28.5. So that bush fits into this space over here, and you will see that the bottom of the bush fits from there until this bottom part of the arm. And if you scroll over to the arm, you're going to find that the arm from there to there is going to be 27, which is the perfect fit for the bush. So the answer to that is 27. If you look at D, the D refers to the across flat of the bolt, which is the M5 bolt. There is a simple calculation to determine the head of the bolt, and that is you take the M5, which is 5 times 1.5, and that gives you the across flat, which is the part here, which is the radius of the head, and that is going to be 5 plus 2.5, and that will give you 7.5 across flat or diameter. Number 11, what is part E called? And part E on our drawing sheet refers to this here, which has thread on both sides, and there is no head to this screw, only the slot, and this is regarded as a grub screw. So the answer to that is grub screw. G-R-U-B, grub screw. Number 12, what type of section is shown at F on the arm? The section here shows the shape, what it looks like, and once it has been placed inside the drawing, it is regarded as a revolved section. The answer to that would be revolved section. Number 13, how many M5 bolts will be used to attach the arm to the base plate? Learners, this is the arm and that is the base plate here, and there will be M5 bolts that will go through here, which is that over there. So we will have to determine how many of those are there. If we scan across, you will find that there will be 1, 2, 3, 4 M5 bolts which will secure the arm to the base plate. Number 14, what is the thickness of the feature at G? This is G here, and that refers to this part here, which is unhatched, and that part over there. That is specifically designed to be in the center of this arm. And if you go and find the actual front and top view of this arm, so here you have the front view, there's the top view, and it is this thin part that you will see here that serves as a web which reinforces this part here of the arm, and the size of that is going to be 7 millimeters. Number 15, what is the purpose of the circlip in the assembly? You will find that that component there is a circlip that fits into a groove of the shaft. There are two reasons why we have a circlip on a shaft. The circlip prevents the spring from shooting out. Once it is there, it prevents the spring from shooting out. Alternatively, it prevents the shaft from falling out of this section here where it's supposed to be fitted. Those are the two reasons why we have a circlip in place. Number 16, with reference to the tolerance, determine the minimum size of the hole at H, and at the same time we are going to have number 17, with reference to the tolerance, determine the maximum size of the hole at H. So here we have H, and H has a diameter of 4, but we have plus 0.25, which is the upper tolerance or the maximum tolerance, and we have minus 0.20, which is the minimum or lower tolerance. So number 16, request for the minimum tolerance. So what we need to do is to take 4 minus 0.20, and that is going to give you 3.80. So number 16 will be 3.80. Number 17, we will have to take the 4 and we will have to add it to 0.25, and your answer will be 4.25 for number 17. Please ensure that you write out the entire calculation to attain 2 marks each. If you look at number 18 and number 19, in the box provided for answer 18 and 19, which you have on your page, you need to draw in freehand the symbol for the projection system used for number 18 and the convention of the spring. Let's have a look. Number 18, here we have the symbol. You will start with your center line, which will give you half a mark. The first circle is a small circle, another circle which is the bigger circle, both half marks each. Then you will have the representation of the line for the small circle, the representation of the line for the bigger circle, and the connecting slanted sections on the side, each half a mark. And for the entire freehand drawing you will receive 1/2 mark. And then if you go to number 19, you will find that we have the convention for a spring. You start out with drawing a center line, and then of course your starter and finish line will be straight or vertical, and then you will have the inside profile, which will be slanted lines, which will result to that symbol being your convention of your spring. You will find a half a mark for the start, a half a mark for the stop. A center line will receive a half a mark, the profile 2 half marks, which is a full mark, and the entire drawing being freehand will receive half a mark as well. Grade 12s, that concludes our analytical mechanical activity. Please make sure that you enter all the necessary answers to those questions which were asked.